Alright, for particle motion, how can we tell if the particle is moving left or right? That has to do with your velocity. If your velocity is negative or less than 0, that means you're moving to the right. If your velocity is positive or greater than 0, that means you're moving to the left. How can I tell if the speed is increasing or decreasing? So the speed is just, is it getting faster or slower? If velocity and acceleration are the same sign, so they're both positive, they're both negative, that means the speed is increasing. If they're opposite signs, V and A are opposite signs, that means the speed is decreasing, it's getting slower. If I have position to get velocity, you just take the derivative. Velocity is just x prime. If I want acceleration and I have velocity, acceleration is just the derivative of v. You also can think of it as x double prime. Average velocity means find the slope. So instead of taking the derivative of x, I'm going to do change in x over change in time. And average acceleration is similar. It's finding the slope of the velocity. So that would be v, change in v over change in time. When we're using the dy dx, so taking derivative with respect to x, derivative of x would just be 1, derivative of y would be dy dx. And don't forget to use your chain or product or quotient rule when necessary. Related rates are all going to be dt's, so relates with respect to time. So if the radius is increasing at 2 inches per second, that's dr dt is positive 2. And then you pick your equation and take the derivative of the equation with respect to time. Here, so we're looking for the equation of the tangent line, which means I need to find the slope, dy dx, at this point. So take the derivative, 2y dy dx minus 2, derivative of 1 times y minus 2x times derivative of y, which is dy dx, minus 1 equals 0. I'm going to move over these two terms. That becomes 1 minus, move over these two terms, 1 plus 2y. Equals 2y dy dx minus 2x dy dx. Take out the 2y minus 2x, so I have 1 plus 2y over 2y minus 2 dx. Sorry, 2x. That is my dy dx. And then now to get the actual slope, I plug in the point. So 1 plus 2 times 0, because this is x comma y. 2 times 0 minus 2 times negative 2, so these two just go away. I've got 1 over negative 2 times negative 2 becomes 4. So then this is my slope right here. And then now we're just going to plug into y, the point slope form. Y minus 0 is just y equals 1/4 x plus 2, because minus a negative. And that is my equation. Number 2, given the curve, I want to find dy dx when x equals 1, so let's just find dy dx in terms of x and y. I'm going to move these over, so that becomes minus y minus 2x equals dy dx x minus 1, and then divide that over. This is the generic dy dx, but I want to plug in when x equals 1. So I've got negative y minus 2 times negative 1 over negative 1 minus 1. So that's negative y plus 2 over negative 2. And then I'm not done because I actually need to find what y is. This is not going to help me find that y value that goes with x, so I'm going to need to plug the x value into the original equation. We've got negative 1 squared plus negative 1y minus y plus 1 equals 0, so this becomes positive 1, so 1 plus 1 is 2. Negative y minus y is just negative 2y equals 0. Subtract over, negative 2y equals negative 2, y is positive 1, so then it's just negative 1, negative y, negative positive 1, plus 2 over negative 2, that becomes 1 over negative 2, which is my answer. Whew. Again, finding dy dx at a certain point, so 3x plus 1 squared, or x plus y squared, times derivative of the inside, equals 3x squared plus 3y squared dy dx. Here, I noticed that every single term had 3 in it, so I cancel out the 3's, and then I distributed the x plus y squared, so this is just x plus y squared plus x plus y squared dy dx. Equals x squared plus y squared dy dx. I'm going to move this over so that I have all dy dx's on one side and non-dy dx's on the other. So that's x squared minus x plus 1, or x plus y squared. And then over here, that would be dy dx x plus y squared minus y squared. So divide that over like this. So that's my dy dx, and then now I just plug in. So I've got -1 squared minus -1 plus 1 squared. Well, that's just going to be 0. And then -1 plus 1 squared again is 0, minus y squared would be 1 squared. -1 squared becomes +1, minus 1 squared is almost -1, so your answer is -1. Here, finding dy dx and trying to put our answer in the simplest form. For a free response, it's okay if you don't simplify, but for multiple choice, you need to be able to look at an answer and be like, oh, that answer is the same. So first things first, take the derivative. So derivative of tangent is secant squared, leave the inside alone, times derivative of the inside, which would be 1 plus dy dx, equals derivative of x, which is 1. Normally I would distribute, but it's actually really easy because I've got this 1 coefficient and 1 over here. The easiest thing is to actually just divide the secant squared over, like this. And then now I just have 1 plus dy dx equals 1 over secant squared. Well, remember, the definition of secant is that it's 1 over cosine. So then when I do 1 over secant, that's 1 over cosine, which just gets me cosine back. Specifically, it gets me cosine squared of x plus y back. And then to get dy dx, you just divide or subtract the 1 over. So this is cosine squared of x plus y minus 1. If you do it the other way, you get secant, so you get, if you do it the other way, you get 1 minus secant squared x plus y over secant squared x plus y, which you could then replace secant squared as 1 over cosine, so that's the same as multiplying by cosine, in which case you get cosine squared, secant is times cosine cancels out and leaves you just minus 1 there. Okay, here this was meant to be natural log of xy equals x squared, so derivative of natural log is just 1 over, and then you'd need to multiply by derivative of the inside. Derivative of xy would be 1y plus x dy dx equals 2x, because derivative of x squared. Here, again, it's easier to just multiply the xy up, so I'm going to multiply xy up like this. That gives me y plus x dy dx equals 2x squared y, subtract the y over here, and then divide by x, so that gives me dy dx is 2x squared y minus y over x. Here, derivative of e to anything is e to the same power, and then you need to multiply by derivative of the inside, which is 1y plus x dy dx, plus derivative of x is 1, derivative of y is dy dx. So I'm going to go ahead and distribute, because dividing by e isn't going to be any nicer. So this is just y e to the xy plus x e to the xy dy dx plus 1 equals dy dx. And then I'm just going to subtract this over, so that leaves me with y e plus 1 equals dy dx minus x e blah 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 dy dx. Factor out the dy dx and divide by that factor, which is 1 minus x e to the xy. And that got rid of this, so then that's my answer. Here we've got x times natural log, so that's product rule. 1 natural log of y plus x, natural log of y would be 1 over y times derivative of y equals dy dx. So I'm going to move this over, so I've got natural log y equals dy dx minus x over y dy dx. So then this becomes natural log of y over 1 minus x over y. Now that is not the simplest form, because we don't want to have a fraction inside of a fraction, so let's multiply top and bottom by y. So that would be y natural log of y. This would be y minus, and then the y's cancel here, which is the whole point, minus x. So this is my dy dx in the simplest form. The particle moves along the axis so that at any time t greater than 0, its position is given here. For what values is it at rest? Well, rest means velocity equals 0. So I'm going to find the velocity by taking derivative, 3t squared minus 6t minus 9, setting it equal to 0, factor out the 3. So this would be 3t minus 3t plus 1. So So then t equals 3 and negative 1, but it said time greater than 0, so I'm going to ignore negative 1 second because that doesn't make sense. So the only really time after t equals 0 that it would change directions is 3. So that means C is my answer. I want to know when it's right, moving to the right, and when it's moving to the left, so we'll just pick a number. Let's say we plugged in 1. That would be, this is a negative, this would still be positive, so that would be a negative velocity. If I plug in any number greater than 3, like 4, that's now positive times positive, this is positive. When it's moving to the right is when I have a positive velocity, so that would be any time greater than 3 seconds, because velocity is positive. And when it's moving to the left would be any time between 0 and 3, because the velocity is less than 0 here, or negative. A spherical balloon is inflated so that its radius increases at a rate of 2 centimeters per second, so that's dr dt equals to, how fast is the volume, so dv dt is my unknown, when r equals 5. So the volume, I already have the equation right here, take the derivative of that with respect to time. So dv dt equals r cubed, the 3 would come down, 4 pi r squared times dr dt. I'm looking for this 4 pi when r is 5 squared times dr dt. So that's 25 times 2 is 50, times 4 is 200 pi dv dt. So what this is saying is that the volume is increasing at a rate of 200 pi cubic centimeters per second, per second, when the radius is 5 centimeters. Velocity of a particle is given here. When is it moving to the left? Well, it's moving to the left when your velocity is less than 0. So velocity is less than 0 from 3 all the way to 10, because this is just where I have negative v values. So that would be 3 to 10 seconds, because velocity is negative. When is it speeding up? So speeding up is when your acceleration and your velocity have the same sign. So here I've got positive velocity, here I've got negative velocities for all of this. I have a negative acceleration here, and I have a negative acceleration here, and I have a positive acceleration here with still a negative velocity. So the only part where they are same in sign is, I said from 3 to 7. So from 3 to 7, because both A of t and V of t have the same sign. I just made a note that they are both negative. For what intervals do I have a positive acceleration? Remember, acceleration is v prime of t, and we get the derivative from a graph as the slope. So this is just the slope of v. So where I have a positive slope is where the graph is increasing. So the only part where I have a positive slope or an increasing graph is from 7 to 10. So time between 7 to 10. And that is because your velocity is increasing on that interval. You could make the note that is a positive slope, but the whole point is that your velocity is increasing. It is like going up, positive slope. Here the velocity is decreasing, not the same thing as speed decreasing, right? Because here the velocity was technically decreasing, but I actually was getting faster. So it's just like velocity is including the direction. So if it's just going down, velocity is decreasing. Not the same as speed decreasing though. The time when the particle changed directions was at t equals 3, because your velocity changes from positive to negative. So it went from moving right to then moving left, so it changed directions. Here we've got position. When does the particle change directions? Well, it can only change directions when it stops, so velocity has to be 0. So first you would find v of t. So that would be 3t squared minus 12t. Set that equal to 0, so I'd factor out a 3t, that's t minus 4. So t equals 0 and at t equals 4. So 0, 4, if you plug in anything less than 4, that's going to give me a negative. And that's going to be giving a positive. So it changes directions at t equals 4 seconds, because velocity changes from negative to positive. B, where is the interval moving to the right? So that is where your velocity is positive. So it's positive velocity from t4 onwards. So t greater than 4 because v of t is greater on that interval. Displacement is just change in position. So I have position right here. So let's find position at the beginning, position at 2 seconds. At 0, it's just 0. Position at 2 seconds is negative 16. So then the change in position, final minus initial, is negative 16 feet. Average velocity would be x of 2 minus x of 0 over 2 minus 0. We actually already found this part, right? So negative 16 minus 0 over 2 minus 0. So that's going to give me negative 8 feet per second. And I know that I was dividing by time here because I don't want to end up with just the change in position, right? I want the rate, the feet per second, so that's how I knew for sure I was dividing by time. Acceleration at t equals 3, so I already have velocity. To get the acceleration, I just take the derivative of the velocity, so a of t, find this first, would be 6t minus 12. And then once you have that, then plug in a of 3 is 6 times 3 minus 12. 18 minus 12 tells me a of 3 is 6, and then feet per second squared. At t equals 3, is the particle speed increasing or decreasing? So v of 3, we've already said that v of 3 would be negative, and we just found that a of 3 is positive. So that means that the speed is decreasing, blah, 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 because a of 3 and v of 3 have different signs. That means the speed is decreasing, or it's getting slower. Next one, your position is given by sine of 2 pi t. To find the velocity, first we take the derivative. Derivative of sine is going to be cosine, so v of t is just cosine of 2 pi t. But you need to multiply by derivative of the inside, which is times 2 pi. So I'm going to rewrite this, 2 pi cosine of 2 pi t. And then I want to find specifically the velocity at 1, so that's just 2 pi cosine of 2 pi times 1 is just 2 pi. If you think of your unit circle, 2 pi is back where you started, cosine at this point is just 1. So this becomes 1, 2 pi times 1 is just 2 pi. So v of 1 equals 2 pi. Now to find acceleration, you take the derivative of the velocity, so a of t, derivative of cosine is negative sine, so this becomes negative 2 pi sine. Still need to take derivative of the inside, so times 2 pi again, so that becomes negative 4 pi squared sine of 2 pi t. That's my a of t. I want the acceleration, wow, I did not give enough room. I want the acceleration at t equals 1, so a of 1 is negative 4 pi squared sine of 2 pi. 2 pi, sine is 0 there, so this all just goes to 0. So a of 1 is 0. Alright, writing expression for the slope, so that's just asking for dy dx. So take derivative, 2x plus 1y plus x dy dx plus 2y dy dx equals 0. Subtract over, so I've got negative 2x minus y over this x plus 2y. Where the points are vertical, the tangent lines are vertical. So vertical looks like this. That means that my slope is undefined. Undefined comes when you divide by 0, which means my denominator must be 0. So I'm going to take my denominator, my x plus 2y equals 0, and I would give you the point just for knowing, like, okay, you know to set the denominator equal to 0. That gives x is negative 2y. So what I'm going to do is I'm going to plug this x into my original position to get the actual values. So x squared, which is this, plus x times y plus y squared equals 12. This becomes just 4y squared minus 2y squared plus y squared. 4 minus 2 is 2, plus another one is 3y squared. Divide the 3 over, y squared is 4. That gives me that y is either plus or minus 2. So I know I've got when y is 2 and when y is negative 2 for y. And then to find the x value that goes with that, well, I have a relationship right here. X is negative 2y, so negative 2 times this y gives me an x value of negative 4. when y is negative 2 times negative 2 becomes positive 4, so that's the x value that goes with it. So these are my 2 points. Now I want to find where the tangent lines are horizontal, so that means a slope is 0, so that just means set the numerator or the top equal to 0. So the top, negative 2x minus y, equals 0. Add over, so that means that y is equal to negative 2x, so then we're going to plug this in for any y. We've got x squared plus x times y is negative 2x, plus y squared, which is negative 2x squared, equals 12. This becomes negative 1 plus 4 is 3. X squared equals 4. X equals plus or minus 2. So I know I've got 2 and negative 2. And then now we just plug in when x is 2, y is negative 2 times 2, which is negative 4. And when y is negative 2, that's negative 2 times negative 2, which is positive 4. So these are the 2 points where, these are the 2 points where I have a horizontal tangent line. I want to show that dy dx equals this. So here, product rule, 1y squared plus x, 2y dy dx, minus 3x squared y minus x cubed dy dx equals 0. Move these ones over, so 3x squared y minus y squared equals 2xy dy dx minus x cubed dy dx. I'm going to factor out the dy dx. 2xy minus x cubed equals this. And then divide over, dy dx equals 3x squared y minus y squared over 2xy minus x cubed. And then you better make sure that it looks exactly like it said, because the whole point is to show that it equals this. So I have exactly what it has, so check, or QED. Here we have derivative of y with respect to x. I want to find the second derivative. So here I already have the first derivative. It just means to take the derivative again. So I'm going to rewrite this dy dx equals 1 minus y squared to the 1/2. To take the derivative, I just pull this down. This is now to the negative 1/2 times, derivative of the inside would be negative 2y dy dx. And then I have 1/2 and 2, so that cancels. 1 minus y squared to the negative 1/2 just means square root of 1 minus y squared. I've got y, negative y right here, and then dy dx, well dy dx is this square root of 1 minus y squared. So then when you see, you've got square root of 1 minus y squared over the same thing, that cancels and I'm just left with negative y. Don't forget the dy dx, and once you have it, don't forget to just, oh, I already have it, I'm substituting in right here. Lastly, water leaking onto a floor forms a circular pool. The radius of the pool increases at a rate of 9. What is the rate the area of the pool is changing when the radius is 15? So dr dt equals 9. We are looking for dA dt when r equals 15. Area of the pool is pi r squared. dA dt is then 2 pi r dr dt. And then that's 2 pi. R is 15 times dr dt 9 to give us dA dt at that specific time. And then this is 30. 30 times 9 is 270, so 270 pi. And then units, this is area, so that would be centimeters squared per minute in this case. That is dA dt. This means that the area is increasing at a rate of 270 pi square centimeters per minute when the radius is 15.